Welcome to our channel Learning Math. In this video, we're going to solve an extra geometry problem for grade 9. Let's start together. Consider a triangle OMN which is right at M, such that OM is 4 cm and MN is 2 cm. We have C is a circle of center O and radius 3 cm, and E is tangent to C at E, and K is a symmetric of N with respect to E. Let's draw the figure in part 1. So here, as you see, we have OMN is a right triangle. OM is equal to 4 cm, MN is equal to 2 cm, and here is a circle C of center O and radius 3 cm. Note something, that from N we draw a tangent to the circle C that cuts the circle at the point E. Sure, since we have a tangent, so it's perpendicular to the radius OE. Also, we have K is a symmetric of N with respect to E, so we have NE equals EK. We can say here that E is the midpoint of the segment NK by symmetry. Now let's refer again to the question. In part 1, draw the figure. Part 2, calculate ON and EN. Let's see how to calculate them. If you note something, here what lengths are we having? We have the length of OM, which is all 4 cm, and MN is 2 cm. Now we need to calculate the length of ON. If you note, we have it given OMN is a right triangle right angled at M. Well, in a right triangle, can't we apply Pythagoras Theorem? How to start by Pythagoras Theorem? Sure, we start by the hypotenuse, which is the line facing the right angle, which is the hypotenuse here is OM. So we start writing triangle OMN is right at M. Then by Pythagoras Theorem, we have ON squared, the hypotenuse squared, is equal to the sum of the other sides squared. So it's equal to OM squared plus MN squared. Now we replace each side by its value. ON we don't have its value, so we copy it the same. While OM is 4 cm, we replace it by 4 cm, and MN is 2 cm, we replace it by 2 cm. We get ON squared equals 4 cm squared plus 2 cm squared. Now ON squared is equal to 16 cm squared plus 4 cm squared, so it's 20 cm squared. Well, we have just calculated ON squared, but we need ON. So to remove the square, we put plus or minus radical. So ON is plus or minus radical 20, but minus is rejected since length. So we can say that ON is equal to radical 20, which is 4 times 5, so it's radical 2 squared times 5. Therefore, ON is 2 radical 5. Now we have calculated the length of ON. We are still needing to find the length of EN. If you note something, we have given that NE is tangent to the circle C at E. Tangent, it means perpendicular to the radius. So here we have another right triangle, which is OEN. Something else, if you note that the point E is on the circle, can't we say that OE is a radius? So in this case, OE is also 3 cm. Now we have the length of ON proved to radical 5. The length of OE is 3 cm. We have a right triangle. Now we can apply Pythagoras Theorem to calculate the length of EN. If you note something, we should start from the hypotenuse. The triangle is right at E, then by Pythagoras Theorem. Even if we need to calculate EN, we don't start by it. We start by the hypotenuse, which is facing the right angle. So we say ON squared is equal to OE squared plus EN squared. Now we replace each side by its value. ON squared, we have it 2 radical 5, so we write it 2 radical 5 all squared equal OE squared, which is 3 cm all squared, plus EN squared, we copy it the same. Now 2 radical 5 all squared, can't we distribute the power? We have nothing between 2 and radical 5, so it's times. So we can write it as 2 squared radical 5 squared. Also the unit is squared, so it's centimeter squared. Equal 3 squared, which is 9 centimeter squared plus EN squared. Now 2 squared, isn't it 4? Times radical 5 squared, isn't it 5? 4 times 5, we can write it 20 centimeter squared is equal to 9 centimeter squared plus EN squared. Well, to calculate EN squared, we should move 9 centimeters square to the other side. We have nothing in front of it, so it's a plus, and here between them plus. When we move 9 centimeters to the other side, we reverse its sign, so plus becomes minus. Now we can say that en square is 20 centimeters square minus 9 centimeters squared, so it's 11 centimeters square. Well, we have calculated en squared, we need en, so we can say that en is plus or minus radical 11 centimeters square, so it's plus or minus radical 11 centimeter. Sure, minus is rejected since length, therefore we can say that en is equal to radical 11 centimeter. Now let's start by part 3. Show that O, E, N and M belong to the same circle whose center and radius are to be determined. This is very important. Whenever we have such a question, to prove that 4 points belong to the same circle, it's enough to find two right triangles that have the same hypotenuse. Note that here we have OMN is a right triangle, its hypotenuse is ON, and also we have OEN is a right triangle, its hypotenuse is ON. Can't we say that ON is a common hypotenuse between these two right triangles? So the 4 points O, E, N and M belong to the same circle whose diameter is the hypotenuse ON. Well, what about the center and radius? If the diameter is ON, then the center is the midpoint of ON. And also the radius is half ON, half the diameter. So it's ON over 2. Then it's equal to radical 5 over 2. We can simplify 2 by 2. So the radius is radical 5 centimeter. So in all of such questions, to prove that 4 points belong to the same circle, we can just find two right triangles having the same hypotenuse. The center of this circle is the midpoint of the hypotenuse and the radius is half the hypotenuse. Now let's start by the other part. As you see in part 4, we have G is a point on OE, such that we have OG equal to centimeter. Also, we have the parallel to OK through E cuts ON at A. Let's see how to draw it first. We have OG is equal to centimeter and we have the parallel through E to OK. When we draw this parallel, it will cut the line ON at the point A. Now let's refer again to the question. Verify that G is the centroid of triangle OKN. Well, in order to understand how to verify that a point is centroid, we should understand something. What is the centroid? It's the meeting of the medians in a triangle. But if we take, for example, triangle OKN, which they are asking about it to prove that G is its centroid, we have here only one median, which is OE. We neither have median drawn from K nor from N. Well, if we have one median only, how to prove a centroid? Here we should find a ratio. If you note something, OG over OE. We have the length of OG and we have the length of OE, the radius, which is 3 centimeter. Well, can't we say that OG over OE is 2 over 3? If we have a median and the distance from the centroid, from the vertex to the centroid is 2/3 the median, then this point is exactly the centroid of the triangle. Okay, so here we can say that in triangle OKN we have the median OE, which is median to KN. We also have the ratio OG over OE is 2 over 3. Therefore, we can directly say that G is the centroid of this triangle. Now again, prove that KG and A are collinear. This question is a trick. If you know something, let's refer again to the given. We should analyze it before starting to solve. What about the point A? What is the point A? We have given the parallel to OK through E cuts ON at A. The parallel through E. What is E? Isn't E the midpoint of the segment KN by symmetry? When we draw parallel from this point, shouldn't it get cut the other side at its midpoint? So here we can say that A is the midpoint of ON. Yes? Now can't we say that KA is a median to ON? Well, KA is a median, then KA should pass through the centroid, which is G. We have just proved its centroid. Therefore, in this case, we can say that K, G, and A are collinear. So we start in triangle OKN. We have E is the midpoint of KN. We have EA is parallel to OK. Then by converse of midpoint theorem, we can say that A is the midpoint of the segment ON. A is a midpoint, then KA is a median. So KA is median to the segment ON. Therefore, KA passes through the centroid G, so we can say that K, G, and A are collinear. Now let C prime be the circle of diameter OK. We have another circle C prime which has the diameter OK. Show that the point E belongs to C prime. Well, we have drawn the circle of diameter OK, so its center should be the midpoint of OK. Why this circle should pass through the point E, and how to prove that a point belongs to a circle. If you note something, we have NK is tangent to the circle C at E. So we have just proved it perpendicular to the radius OE. So we have NK is perpendicular to OE at E. Therefore, we can say that the angle OEK salient is equal to 90 degrees. Now, can't we say that it's as an angle inscribed facing the diameter? To prove that a point belongs to a circle, which is here C prime, we have just to find a right angle exactly at this point. It will be an angle facing the diameter. If you note here, OK is the diameter of C prime, circle C prime. The points K and O are on the circle. They are diametrically opposite, and we have K EO is equal to 90 degrees. So it's an angle inscribed facing the diameter. Therefore, we can say that the point E belongs to the circle C prime. Now C prime cuts the circle C at a point B. If you note it, we have here is the circle C prime. This circle cuts the circle C at the point B. It also cuts the circle C at the point E. We have just proved it on both circles. And it also cuts the circle C at another point, which is, as you see here, the point B. Now let's see the question. Prove that BK is tangent to C. Well, how to prove a tangent? If you know something, to prove that BK is tangent to the circle C, it's enough to prove it perpendicular to the radius. So we need to prove that KB is perpendicular to OB. But if you note something, we have brought the given that B is a point that is the intersection of the circles C and C prime. So we can say that B is a point on the circle C prime. Now can't we say that KBO salient is equal to 90 degrees as an angle inscribed facing the diameter? Well, here we have proved that KBO salient is equal to 90 degrees. Therefore, we can say that KB is perpendicular to OB, and OB is a radius in the circle C. Now, can't we say that KB is tangent to the circle C at B? So, therefore, we have KB is tangent to the circle C at the point B. Now, deduce that BK is equal to radical 11. In each part in geometry, we should pay attention to the previous one. We have just proved that BK is tangent to the circle C. Well, how many tangents are we having to the circle C? If you note, we have the tangent Kn. Exactly from K, we have the first tangent, which is Ke to the circle C, and the second tangent is Kb. We have just proved that. Can't we say in this case that Kb equals Ke? They are tangents from the same point to the same circle? Well, Tangents from the same point to the same circle, so we can say that KB is equal to KE. But also if you note, we have KE is equal to EN by symmetry. And we have just proved that EN is equal to radical 11. Therefore, we can say that KB is equal to radical 11. Hope you have enjoyed this video. Please like, share, and subscribe for the continuity of our channel. Thank you for watching.